So let's look and see where we are. We're going to stop for now. We're going to look and see where we are. So were you guys able to set up a Gisha model? Did your reservoirs, were you able to set up a reservoir? Or whatever you needed to do. Are there any questions about what we've done?
I think everyone now did something different than the other. For me, I did Gisha. Some people did floodplain, other working very perfect. So
yeah.
the moment we didn't have any problem.
We didn't have any purpose? Okay.
Problem, no purpose.
Problem, no problems. Okay. So so we've talked about how to set up different scenarios. And so, for example, if I have a wetland, what happens to my hydrograph? If I had a detention basin, then how does that affect my hydrograph compared to the original hydrograph? So now what we're going to talk about is how do I, if I have a Gisha model already set up, how do I calibrate my Gisha model? So let's say I have a Gisha model and I have some calibration data, so I know what the flow rates are, or maybe I know what the infiltration values are for the area where I'm doing a Gisha model. I can calibrate my Gisha model to get it to match some observed data. So let's look at how to calibrate a Gisha model. So first of all, I'm going to read in a Gisha model that I've already created. And so I'm just going to read this file into WMS. So this is a Gisha model that I have already created. And this Gisha model has a bunch of precipitation gauges. I'm going to turn those precipitation gauges off. So here's a Gisha model. And if I run this Gisha model, let's go ahead and run it. We'll see how it is. So we're running this Gisha model. Seems like, I think we got an error, so I'm going to try that again. Run simulation. Save this out. Okay, then Gisha runs. I can just make sure that Gisha is able to run this simulation that I've created. This is a long-term simulation, so it takes a little bit longer to run the simulation, but hopefully it'll finish soon. Okay, actually I'm gonna close this. So maybe I read in the wrong model. Let me look at my job control. Yeah, I actually already have calibration defined. I need to read in a model that does not have calibration defined. So let's see. This is my original model right here. And this model, if I go to the job control, I'm doing a long-term simulation. I haven't defined any calibration data, and so that's all set up. If I want to calibrate this model, the way to do that is there are a few steps. The first step is I need to define what parameters I want to calibrate. And the way you do that is by defining parameters with negative values. So I can go to my map tables, and let's say I want to calibrate all of these roughness values, so I would just enter negative values for these roughness values. And if I want to do them all separately, I enter different negative values. So here's -1, -2, -3, -4, -5. So that means I'm going to calibrate the negative value. It has to be an integer. It means I'm going to calibrate each of those values. Then I'm going to go to my infiltration data, and we're going to calibrate the hydraulic conductivity for each of these. So -6, and they have to be unique values. -7, and I'm going to calibrate each of these values separately, so up to -14. I can also calibrate some job control parameters, so I'm going to go to my job control, and I'm going to calibrate the soil moisture depth, so that's -15, and the top layer depth will do -16. Yeah.
I don't understand what does this negative value mean. I thought calibration is to compare two time series together or two chip files together. But what does it mean to put -15? Of course,
that means the variables with negative values, those are the variables we're going to calibrate. And we're not entering time series data yet, entering observed data yet. But so I'm just defining which variables I want to calibrate.
So negative values means calibrate this value?
Yeah. So then what I do is I go to my job control, turn on this calibrate option, and go to edit parameters. In this window, I don't have any calibration parameters defined. But to define those parameters, WMS will go through my whole model. Any negative values will be used as calibration parameters. So the way you do that is you select this initialize parameters from model. That'll go through my model, and any negative value, all my negative values are displayed here. So these are my values that I want to calibrate. And these negative values, those are called key values. So those are the key values that are used in calibration. For each of these values, I need to enter a start value, a minimum value, and a maximum value. Okay, my start values, I'm just going to get from my, I have a workshop here. So my start values I'm going to get from, and that's usually what you started with, but I changed the negative values. So I can just enter some start values here. So here's all my start values. Here are my minimum values. Here are my maximum values. So we're just going to go through and enter these start, min, and maximum values. So Gisha, job control, calibrate, and we're going to enter all these values, and it's kind of hard to see, but I'll make this a little bit bigger. So my start value, we're going to go down 0.0595, 0.4071, 0.1051, 0.8408. I guess I did an extra, yeah, I calibrated an extra value, but that's okay. Anyway, I can go through and define all of this information. Okay, the next thing I need to do is go to my observed data. And in my observed data, I add an observation. And you can have different kinds of observed data. So I can have observed data at my outlet point. I can also define observed data internal to my watershed. So if I don't have observed data at my outlet point, I can define my observed data somewhere inside of my watershed. And then I define that observed data, what that observed data is. So you would define a time series. And so here in my workshop I have a time series of observed data. And it's called observed.text. So here's my observed data. I'm going to copy that and I'll paste it into this. So this is my hydrograph that's observed, my observed hydrograph. And I'll just call this OBS for observed. Okay, and then I can define what we call weights for that observed data. By default, all the weights for the observed data are going to be 1, but if I want a higher weighting to be added to my peak flow rate, I can change the weight for the peak flow rate. I'm just going to leave all the weights at 1. And then I can set up my calibration parameters. So these are the different calibration options that are supported in Gisha. There are several different options. Usually I use just the default option. The default option is a local, there are global calibration methods and then there are local calibration methods. The default is a local method that just a local search method. If I wanted to do a global search, the method that we recommend is this MLSL, multi-level single linkage method. So if you wanted to search all the range of parameters, it takes a lot longer to do a global search, but that's the option you'd want to use. So I define that. I've defined my observed data, and I need to finish defining these min and max values. And there are a bunch of other options you can define here for calibration, but the main thing is just define your min and max values, your start values, define which variables you want to calibrate, and then define your observed data in here. Once you've done all that, you can go ahead and run your model, run your Gisha model. So are there any questions about calibration? Do you have questions about that, how that's done? One thing I wanted to show you is if I have some calibration data inside of my watershed, so let's say I have calibration data at this point instead of at this point in my watershed instead of at my outlet point, you can double click on this point or just go to the attributes for this point, and then you can define your observation data at that point. And the types of observation, so these are the different types of observations you can define. All these different types. So let's say I know what my channel depth is at that location. Then I can go in and define my channel depth over time at that location. And then Gisha will calibrate to this observation also. So if I go to back to the job control and go to my observed data, Gisha can calibrate to that location also. And then when you run the calibration, it'll calibrate to both of those observed data points. So any questions about that? There's a workshop that shows you how to set up a calibration. And so you start out by defining which variables you want to calibrate, and then you define the calibration, the observation data, and then you just run the calibration. And it has you add some internal calibration points. So if I were to go to this workshop, it has you first define these calibration, the data you want to calibrate. Then you define your observed data. Then you define the method. Then you run your simulation. You run your calibration. And then you add some additional observation points. And these are the different observations you can calibrate to. So you can calibrate to overland flow depth, infiltration depth, surface moisture, channel depth, channel flow, groundwater head, outlet, your outlet hydrograph, the outlet point, snow water equivalent, which you probably wouldn't use, and also tile drain discharge. You can calibrate to all those different observations, and it explains how to calibrate to those observations. So that's calibration. That's all I want to say about that. The other thing we're going to talk about is what's that? Say it again. The parameters. Yeah.
Where can I find these parameters?
Which parameters?
Which I run the calibration. I do the calibrations for these parameters.
The observed. Where do you get the observed data?
Yeah. No, the result of the calibration.
Where do you get the results of the calibration? So when you run the calibration, so after the calibration is done running, then WMS is going to bring up this window right here that allows you to select, and if you're just doing a local search, then this window is going to come up and there will only be one set of optimized parameters. But if you're doing a global search, you're going to have several options for optimized parameters. And you usually want to select the one with the lowest objective function value. So if you're familiar with calibration, you try to get the observed data as close as possible to your computed data. And the difference between the observed and the computed data is called your objective function. And you're trying to get the lowest value for your objective function. And so this window is going to come up after you run your calibration. When you hit OK on this, WMS will replace the values, the negative values, with the calibrated values. So that's this checkbox. What's that? Yeah, it'll replace the negative values with your calibrated values. And so these are the calibrated values right here. These are the starting values. These are the calibrated values. And this checkbox will allow you to replace those negative values with the calibrated values. And then you'll run a final simulation with those calibrated values. And that's how you run the calibration. And then when you run the final simulation, you have a calibrated model with it's just calibrated values. So any other questions about it, about calibration?
For the calibration, still, as my colleague asked about the calibration for the discharge flow for long-term analysis.
Yeah.
Does it also include in this part, or we will have it later?
Yeah, so you can calibrate your discharge for long-term analysis, and you just set it up exactly the same way I showed you here. So you would, and you can calibrate the same parameters. You would calibrate your losses, maybe your Manning's roughness values, whatever you want to calibrate. You just define negative values for those. And then you define your observed long-term data. So your observed hydrograph, just like we did here. And actually this is actually a long-term simulation. See, if I go to job control, this is a long-term simulation. And so you calibrate the long-term simulation just like I showed you right here. Short-term simulations are going to be the same thing. You define which parameters you want to calibrate, then you define your observed data, and then you just run the calibration, and then WMS will calibrate to that observed data. So does that answer your question?
Yeah.
Okay.
Because I think I should say about how I define the long-term simulation, from my point of view, it's about years. It's like, as you mentioned before, if I use that WMS and these models with one store, it is looking just for one store. But if I use it, for example, for 1 month, maybe it has two or three stores maximum. But for me, I normally simulate, or like using the models to simulate for long term. 15 years just to study the hydrology of this basin, for example, the Nile basin, and I have daily data. And so far, I really don't know. Sometimes I find Gisha is the suitable model to be used, and with the assumption about the long-term analysis that I'm dealing with, I feel that it's not the suitable model. So
Okay.
what do you recommend, or like, because I'm still, this is my first.
What do I recommend for long-term simulation?
Yeah. Do you recommend it really for the Nile basin with the long-term simulation for daily?
And you have daily precipitation data.
Yeah. Do you think?
Yeah, you could probably use Gisha. I mean, I don't know if it's the best model or not. So there are three different models you could use. There's Gisha, there's HSPF, which we weren't planning on talking about, and then there's HMS. All those models do long-term simulation, and you could use HMS, you could use Gisha, or you could use HSPF for doing that. And all of them, each of those models has advantages and disadvantages. The problem with Gisha is it would take a long time to run. If you're doing several years worth of data, it's going to take a long time to run Gisha. And the other problem is if you only have daily precipitation data, Gisha is going to assume that precipitation happens at one time at the same time each day, and that may not be what happens. You can actually, there are tools that are included with WMS that we'll talk about when we talk about long-term simulations, but there are tools that allow you to change to kind of redistribute your precipitation. So you can convert from daily data to maybe hourly data. But you would have to do that probably to use it in Gisha. Otherwise, Gisha is just going to assume that rainfall happens all at one time during the day.
Okay. But we will talk about this later, about these tools in case.
Yeah.
Last thing about the calibration, normally I know that after we do the calibration, we need the validation of the model. Like, does it also include with the Gisha model to have the validation? You know what I mean?
You mean comparing the observed and computed hydrographs?
Yeah, after the model is calibrated, does it have also the same, or shall we do it also manually, like to repeat the calibration and to see the parameters for a different set of data?
Yeah, so you can compare the observed and the computed hydrographs. Is that what you mean? Or are you talking about comparing the pre-calibrated hydrograph to the after you calibrate?
No, yes, after the calibration. Normally, we have observed data. We don't use the whole data for the calibration. We use a part of it, especially for the long-term analysis, like a part of it for calibration, and the rest is used for validation, to validate the calibrated model.
Mm-hmm.
I'm not sure. You look at one?
Yes, you're saying you would calibrate using a small subset of the observed data, and then you would validate the model using some other observed data?
Yeah.
Yeah, you could do that.
Like for example, for SWOT model, it has the two components to assign a part for the data for calibration and the rest of the data for validation as one component. Does it have the same with Gisha model, or I know the concept, then I can apply it within the model?
Yeah, I mean, you could, after you've calibrated your model, you can run your model for any time period that you wanted. And then you would compare your observed and your computed hydrographs for that new time period.
Yeah, and in case if I find differences and I have to recalibrate my model again?
You could, or you could just calibrate it to all of your observed data. And for validation, maybe you have some new observed data, you validate it to that. So.
How we can run the movie, play the movie that shows the movement of blood?
On yours or on this one? On this model? I'll have to show you some. I'll have to show you later. Okay. So, let's look at the schedule here. So the other thing I wanted to talk about is I want to talk about creating Maud-Clark models. Maud-Clark models. So Maud-Clark is a method that is in HMS. HMS has a 2D model also. Okay, so I want to talk about setting up a 2D model in HMS. So the first thing I'm going to do is, let's read in this some elevation data. We'll go to Sinai. We'll read in some elevation data.
Excuse me.
Yeah,
You say that HLS has a 2D,
yeah.
so in this case, it will run as a long loop or distributed.
It runs as a distributed model, 2D model.
As the Gisha.
And yeah, well, similar to Gisha, it's called a quasi 2D model. It's called the Maud-Clark model. And what this is, it's a version of the Clark unit hydrograph method that instead of defining the time concentration for just the whole basin, I define the time concentration for each grid cell, for a bunch of grid cells. And so first we're going to read in some data. Here's my elevations. I'm going to convert that to a DEM. And I'm going to read in some images. Okay, and then I'll just use the watershed delineation wizard, and we'll run through the hydrologic modeling wizard to create this model. So I'll define a file name. I'll call this Sinai HMS mod Clark. We'll define our projection. So UTM zone 36 is our projection. We can define our project boundary. There's my project boundary. And then I can read in my files. I've already read in my files, so I'm not going to worry about reading them in. We'll run Topaz. We create our outlet point for the area we're interested in. So let's create an outlet point. Maybe right here. Then we'll delineate our watershed. There's my watershed. Then we select, instead of selecting Gisha or HMS, we're going to select HMS mod Clark. Okay, and that's the modified Clark method. This is the quasi 2D model that's part of Gisha, or part of HMS. We'll initialize our model data. Then I define my cell size for the grid that I'm going to use. So the cell size, let's just do a cell size of 200 meters. We'll create our grid. We're going to get our elevations from our DEM. And so there's our grid. With the elevations defined from the DEM. And then I just set up my model like any other Gisha model. So I'm going to define my starting and ending time. We're going to go from 5:22 to let's do 5:24, so 2 days. Just define a starting and ending time. You define a time step, so I'm going to do a 5-minute time step. That means I'm going to get output every 5 minutes. And then I can define my curve numbers. define my curve numbers, I need some land use and soil data. So I'm just going to assume this whole area has the land use and soil data is the same for this whole watershed. So I'm going to create a new coverage, and we'll create a land use coverage, and we'll define a polygon for our land use, and then we'll build that polygon. Then I'm going to just duplicate that same coverage, and I'll change this to be a soil type coverage. So for my land use coverage, let's say my land use is rural, and my land use ID, whatever. And I need to define curve numbers for that land use. So my curve numbers, let's say I have 85, 90, 95, and maybe 97 for my different soils. Then I go and define my soil type coverage. So my soil type, let's say this is type A, or type D, which is low infiltration rates. Okay? Apply that. So I have my coverages defined, then I compute my GIS attributes. And so this is a little bit different dialogue than you've seen. Before we had a window that was for lumped parameter models. This is for the HMS Maud-Clark method models. And I'm going to compute my curve number using WMS coverages, and we'll just hit OK here. And what WMS does is it creates this, what's that?
Are you recording?
I think so. Yeah. Still recording. So what HMS does is it creates this data set that has my curve number, and the curve number is going to be the same everywhere, because so if I select a cell on this grid, my curve number is 97 everywhere. Okay, so over here it says 97. That's my curve number. Also, I need to compute the time concentration, and I have two options. Well, for the Maud-Clark method, you always want to use basin data, and you select a method for computing the time concentration. Let's just use the Kirpich method, and this is my TC, but WMS is actually going to compute a time concentration for each cell on my grid, and then that's kind of how the Maud-Clark method works. Then I'll edit my parameters. And for my parameters, I'll do the loss rate method. I'm going to use gridded SCS curve number. So I'll change this to gridded SCS curve number. I define some parameters here. And I'm just going to use the defaults. Then I define for transform, I'm going to use the Maud-Clark method. Maud-Clark transform. So I'm changing this to Maud-Clark. And I already have selected a method for computing my time concentration and my storage coefficients. Then I hit OK. So I've defined pretty much everything. I also need to define some precipitation. There are a couple of ways to define precipitation for the Maud-Clark method. One way is you can use gridded precipitation. So if you have some gridded rainfall data for different time steps, you can select this button and define gridded precipitation. So you add their ArcInfo ASCII grids, WMS will read ArcInfo ASCII grids. You define gridded precipitation for several time steps. I don't have gridded precipitation for this area. So I'm just going to use a user hyetograph. I'll enter a total rainfall depth of let's say it rains 3 inches, 24 hours. And we'll do a type 2 24-hour storm. And then we'll clean up our model. We'll redistribute our vertices as part of that. It says no errors were detected in your HMS Mod Clark model. So that's good. Then we can save this project. And then if we try to run it from here, we're going to get this message that we need to save it out. So we go to HMS, save HMS file, and we'll save this file to, we'll make a folder called HMS Mod Clark. And we'll just save it here. So this file is saved to HMS. WMS writes some DSS grid files. That's what this writing DSS file is. It's writing some DSS grid files that have my Mod Clark information. And then I can start up HMS. So here's HMS, and we'll read this project into HMS. So we'll go here to Documents, Demo, Sinai, HMS. So here's my HMS project. And part of this is I have gridded data, so I have gridded precipitation and gridded STS curve number. The precipitation actually isn't, we save it out as a grid because you have to have gridded precipitation if you're doing the Mod Clark method, but it's actually the same value for each grid cell. Then I can just go to compute and we'll try running this simulation. It takes a little bit longer to run a Mod Clark method. And then we can look at the results. So here's my precipitation, here's my hydrograph in that watershed. Really, it's not very much different than just setting up a regular HMS model. And HMS, it doesn't show you the grid. It doesn't show you the gridded data. You can't view the gridded data in HMS. You only view the gridded data in WMS, then you export it to HMS. And HMS runs it as a Mod Clark model. And it doesn't compute spatial depths like Gisha does. But so this is the gridded method that you can use in HMS. And I'm not sure, it probably doesn't compute really any other information more than what a regular HMS model computes. So it doesn't compute spatial parameters. It's just you have spatially distributed input data instead of lumped parameter. It's not a lumped parameter model, it's a spatially distributed model. So any questions about this? Mod Clark method, yeah.
This is not used in long-term simulation.
Are you saying that, or are you asking?
I asked, is it a yes or no?
Okay. So let's see. You might be able to use this for long-term simulations. I have never used it for long-term simulations. I've just used it for short-term simulations. I don't know if anybody has. So if you did that, you'd be the first person in the
No, I
world.
asked you because, as you know, it's not going in the sequence of long-term. So I asked if there is an option, another option.
Is there an option to run this long-term?
I don't say
There's not really an option. You can, you probably can run long-term simulations with the Maud-Clark method. The thing that you would need to do, so the thing I didn't show you is that WMS you can, for long-term simulations in HMS, you're going to want to use the SMA method, like we talked about yesterday. And you can compute gridded SMA parameters. So you can compute all those parameters. Anyway, there's a big list of parameters that you have to compute for the SMA method, and you can compute those. You can compute those for your grid here. So your canopy storage, your surface storage, your impervious area, and then all these different SMA parameters, so your infiltration rate, storage, tension, percolation. You can compute all those for your data, for your grid. And so what you would do, I mean, I didn't explain this, but what you would do is you define for your land use, you define your SMA parameters for your land use. So these are the SMA parameters for your land use. And then for your soil type coverage, you define those for the soil type coverage. So these are the SMA parameters for that. And then you would compute those parameters over your grid, and then you would save it out. You would you enter some long-term precipitation data, save out your HMS file, and then it would be a long-term model in HMS. So that's how you do the long-term gridded data in HMS. If you're doing curve number like I showed you, you probably would not want to run that long-term, because the curve number, it just assumes a constant curve number through your whole storm, which probably isn't correct. So use the SMA method. Yeah. Yeah, so it will improve the hydrograph if you use the gridded data. Instead of being a lumped parameter model where it lumps all the parameters into a single point, it's going to you're defining your data at each cell in your grid, and so the results should be better. I mean, people have done studies and found the results match the observed data better if you do this. But like I say, it doesn't compute the depths. It doesn't really compute a two-dimensional output. It just computes the hydrograph. So that's the HMS Maud-Clark. That's how you set up an HMS Maud-Clark model. Yeah.
I heard you talk about precipitation.
About what?
Precipitation.
Say that one more time. What is it? The Kerpitch. Kerpitch. Yeah.
I think it's only valid for agriculture land.
Okay. It's only valid for agricultural areas. Okay, so you can select. I don't know. There are so many equations. You'd have to look up the.
I think Kerpish in particular is only valid for agriculture.
Okay. All right. So maybe we used the wrong equation there. We could use one of these other equations. So we use the Kerpitch. Maybe we don't want to use the Kerpitch. Maybe we want to use one of these other methods. So, or you can just define your own equation. So you can modify this equation, define your own equation, right? All right, any other questions before we keep going? Do we need to take a little break? Yeah, let's take a break for 10 minutes, and then we'll talk about talk a little bit more about Gisha. Okay.
We don't have how to convert the negative file into Gisha.
Yeah, we could do that. We could talk about how to convert an HMS project into a Gisha project. So let's take a break till 4:40. 4:40. Then we'll start back up. And we'll finish up at 5. So I'll talk at 4:40. Now tomorrow when you come in, we're going to do some workshops. We have this workshop for Gisha calibration. It shows you how to set up a calibration model, how to calibrate your model in Gisha. We also have a workshop. The other thing that I'd like you to do is to set up a Gisha model for an Egyptian watershed shed. So if you haven't already set up a Gisha model for an Egyptian watershed, we're going to work on that tomorrow morning. And anyway, so let's break until 40 minutes after. I'll start up. Did you have a question?